So it says that a pinball is launched with a pinball plunger up this, and then it goes into a cup, and they both go up the ramp. And we know the angle. We just have to figure out the distance that they both go up before they slide back down. And due to the conservation of energy, we know that the initial energy is going to be equal to the energy at this point. So we can use the equation of the potential energy here is equal to the kinetic energy, and the translational energy, kinetic energy is equal to the rotational kinetic energy of the ball. So using those, we're able to figure out the velocity that it's going to travel when it goes up. And then we also know that the potential energy here is going to be equal to the potential energy here, because once it hits the top, there's no energy. So they're both potential energies there. And then we're able to figure out the distance that it travels before turning on and sliding back down. And for this problem, it says a thin hoop rolls smoothly towards a large curved movable ramp, which can also roll smoothly, and that's at rest. So when it rolls up the ramp, it reaches its maximum height right here, and we have to figure out the speed when it reaches maximum height and the speed of the ramp after it rolls down. So since the conservation of energy states that energy is lost because it is frictionless, so there's no energy loss there. The initial energy here is going to be equal to the energy at the end, which is the translational kinetic energy and the kinetic rotational energy. So those can be set equal to the potential energy at the end. Since the hoop is no longer rotating at its maximum height, it's basically still, and there's no kinetic energy, just potential. And that is able, yeah, so we found that, and then we're able to solve for the moment of inertia using that to find the maximum height.